Hi friends, so today uh, we are into our last but one module, that is week 11 of risk conscious operation management of complex engineering system. You would have seen one thing, that is the subject that is being discussed or presented here, it has got some component where we were using knowledge that was available in our holy books, religious books, because knowledge anywhere should be used. It has got that stamp of quality, number one. And then we have been discussing somewhere a very thin line, between application and theory, risk modeling and all. And these are, we have been connecting ourselves to the state of the art and at the same time advancement. Today's lecture, now whatever we have learned, all these maybe 10 weeks, we are putting into the application. In fact, before that also we have discussed many applications, but here is a very big subject, that is the maintenance management. So risk conscious maintenance management. We will be seeing the maintenance management in the risk perspective and in the human involvement perspective. Conscious term has come because of that, because this is very important. It is a very human interaction intensive activity, maintenance management anywhere. Maintenance task per se and maintenance management and of course there the organizational aspects are also involved. So we will be discussing in a holistic sense, and in this week we will be introducing, like in the first lecture, introduction. Then we will try to understand the basic concepts of risk conscious test and maintenance, because there are two major activities in the plant which interface with the operation. One is testing for safety system and other one is maintenance management. In testing also maintenance activities they play a very critical role. So if I have to talk about the outline of this this particular week, it will be like, first in first lecture we will see the introduction of the subject, then fundamentals of risk-based, risk-informed approach in, now I am using the word here RCT, risk conscious testing and maintenance management. I think you will get to know, I have given the abbreviation at the bottom. And then risk conscious maintenance management system, of course, what are all the parts and factors and then component of risk conscious maintenance management. When I say maintenance, the testing is implicitly involved actually, and then the traditional approach to test and maintenance interval optimization, like linear programming methods and all. And then to make it, like, on fifth lecture, we will be going into the R&D domain. That means we will be using artificial intelligence approach to RCTMM. And it's going to be very interesting for all of you. And please remember that whatever is being taught here, you can relate it to academics, and then you can develop your own applications. And unless until we have real-time applications, R&D doesn't have much value actually. Thank you. So let us go on. This is symbolic. I am shown that the way we treat hardware. And see, if we don't treat the human in the same way, so then the health of human factor, they are related to technology. So whatever technology we may have, they will work and they are developed by human, they are operated by human, and there is a human aspect, that is we are taking this thing from our healthcare systems. So the way we maintain health of humans, we are discussing here how we can manage, and system could be electronics, electrical, and of course it is a synergy of all the system, mechanical, structural system. So it is just symbolic, and that I want to bring that focus, that human and hardware, they are integral part of any system or plant level operation. Okay, so first question will come to our mind, why risk conscious maintenance management? A simple answer will be, maintenance activities are human interaction intensive. We have been telling that operation ecosystem, actually operation and maintenance, they are not treated separate. For the sake of having a very smooth conduct of operation and all, there can be a maintenance department, but basically O&M, it is called operation and maintenance, So they are intricately woven with in an integrated fabric, and then traditional maintenance approach, yes, we have to discuss, because the contrast we will be able to see from there only how much we have evolved and what are all the future direction that is required, and then limitation of traditional approaches. Of course, that will only give us the valuable information. Idea is not to criticize the traditional approach. World War I, II, they did a very good job, and that was an opportunity for learning, and from there all later on maintenance strategies, I would say, they evolved. And now what we see, in the coming slide, we'll be seeing all those things. Now it is more of like, online measurement, and because technology is available, data is available. And then, as part of this maintenance evaluation, and two case studies. One case study is straightforward, one single objective function, and second case study will be AI based. It is more of R&D, brainstorming. If you have multi-objective function, then minimum for anything will not be available, but there will be some optimum solution combining all the objective function, and that is called the best estimate that can be obtained. But that cannot be obtained through linear programming approaches, traditional approaches for maintenance and maintenance. So I said, why RCCM? This question should be asked, before we go ahead into it. So one thing is very simple, that one factor was human factor that we have been discussing here, and then second thing is systems have become very complex and demanding. Now we want throughput from the plant. At the same time, we want to maintain a very highest level of safety or risk reduction to the minimal acceptable level. Okay, so that is one thing. And then we have nature of activities. Yes, whether it is a skill-based task, maintenance activities, you would like to see them as a skill-based task, but there are a good component of knowledge-based task and rule-based task also. So like in risk-based engineering, there is a fundamental assertion that any job we take, it might have a component varying, it may be having 80% skill-based task, like welding, it may be skill-based task, but a person who has got good knowledge and good rules where and what to do, he is called the best welder, a lathe machine operator. He knows not only that giving a shape to the subject piece of material, but he also knows how to improve the quality. So that is where, so all the jobs are mixed up, they are not in isolation. Any job we cannot treat them either it is skill based, knowledge based, or rule based. So that is a quality attribute for all the jobs. Maybe a control room scenario will require a more knowledge based attention. That is understandable, but there also the feel of so many alarms, what is going on, and that is related to rules, So this is the broader perspective for risk-based engineering on which this subject is based. I wanted to talk about it. And maintenance to a great extent is a function of volume of human interaction. That means more, so that's why in maintenance also, it is basically now we are going to the replacement strategy, because once the part becomes old, aging, it requires the kind of expertise which only expert can do. And second thing is, it takes time and resources, and then you are not sure how it is going to be. So those kind of changes we are seeing now. Look at our printer, look at our computers and all that. So that way human interactions, repair and replacement, these are the two major areas. And if we talk about the plant ecosystem, then there are many areas which can be attributed to commissioning and coordination. there is a control room, activities going on at the site, what is communicated from the site should be interpreted properly in the control room, and what instructions have been communicated to the site has to be seen in the perspective, because control room has got almost every area connected, So it is something like you are taking a local system with the global system, and this communication and coordination is very important. And error in maintenance, yes, if the activities are complex, then chances of error, and where it requires very highly skilled task, then if we have even little compromise in skill based things, then we have issues. So error in maintenance is one of the important, and most important part of error in maintenance is latent error, something which the equipment was declared operable, but some error remained passive or latent, and that gets precipitated only when after some operation or some set of operation where the aging was the phenomena, or where, latent error can be with the electronics, it can be with the mechanical, it can be with the electrical. It's a very important component, and that error, if it is it is got a common cause. Suppose oil is made up as a part of maintenance in a bearing, but the oil happened to be spurious, then the common cause failure related to human, because of course we say it is quality related, but then at human or organization level it should have been checked. So this is why risk conscious maintenance, that means more human based and very thickly controlled and operated system. Now, if you want to see the larger perspective, then again we have to come back to our life cycle curve. See, any component we take, it has got its own life cycle. That means its initial period performance might be different compared to that 90% of the period it is going to operate or function for the period. So this initial period is called infant mortality period also, traditionally in bathtub curve, and then useful, because all the quality related issue, learning related issue, lack of learning related issue, and there are many things which is called when the systems are assembled, then in assembly way there could be new mode of failure and fault. So those they gets precipitated out here, and then finally what you have is useful period. Now in the bathtub curve there is an assumption, or life cycle curve, there is assumption that this is a useful period, and its failure rate or probability density function is constant. Now theoretically we told, yes, generally it is a good period because component give very good service, but we have to understand, this is another way why risk conscious maintenance management is required. The way we understood the degradation mechanism, the small degradation mechanism we are showing, we perform the maintenance and bring it to the reference level. Okay, so these are various maintenance activities which goes on. If I remove this maintenance activity, then the aging or degradation might start somewhere here only. But maintenance activities are, so there is a theoretical side to it and there is a practical side to it. It is through management, and that is why maintenance management has become a real. Okay, you do maintenance and then finally the systems come back and it gives normal service. But after some time, this period could be around, let's say for mechanical system it could be 30 years, for structural system it could be something like 70 years or 60 years, whatever. But eventually the aging starts and it translates or it manifests into something like more frequent failure, and the failures are such that through routine maintenance it cannot be controlled or it cannot be brought to normal. So that is where the aging period, and we have this called refurbishment program, that means extended maintenance management program, and that's how this curve. So we have understood the importance of maintenance, role of maintenance, and what we do. So what we do here, I think in previous presentation we saw that we do aging management program and bring the plant to reference state, and again we have this bigger portion of that useful period, and of course. So this is a good input to understand. If I have to understand it more closely, how to how to have a Bartók curve or some life cycle curve at the plant level. That was at more or less what we discussed in the previous slide. It was at the component level. Okay. So now, and those component level curve we obtained by putting so many component, a population of so many components into test, and how those like electric bulb or whatever item you take, and then we put 100 electric bulb, how they fail, and then how we do after you remove those things, it becomes a constant failure, and then finally aging failure. But here in plant, it is a synergy of multiple component, thousands or lakhs of component, they are operating together, and their performance is reflected in plant unavailability. So plant unavailability becomes a matrix here instead of probability density function, and then we see that initially when the plant was started, the availability was poor. I mean, you can have a look at any system. Normally we try to reduce this quotient, through quality control, better training, and then assembly related errors and all that. But still you will find an element of initial period, and once that is over, we understood the plant, now we are operating, and useful period comes, and then the aging after some time, let us say 40 years at plant level, the aging symptoms again come, and then unavailability increases, and finally you take up the refurbishment program. Extended maintenance is always called a refurbishment program, and then again your plant start at the reference level of useful period, and we continue. Okay, this is the assumption. If everything is done and the plant comes back to the same level, it is an assumption. It could be little more, little less, but in principle, yes, this is the presentation for extended life cycle curve actually. Now, how this maintenance approach they have evolved. When the First World War, Second World War, it was found that the equipments were breaking down in the field, and then what maintenance? So breakdown maintenance was resorted. Okay, and that gave relief at that point of time. But then people thought, why not we have an improved strategy wherein the breakdown, replacing the component or repairing the component after breakdown, it is like it is at the industrial level, in that ecosystem, it is very you can say expensive approach, because plant is shut down, so we are losing the revenue. Why then only this redundancy and all those things in the configuration mode they came up. Okay, if one equipment fails, the breakdowns, other will be there to take care. But even that is not sufficient. So the concept of maintenance shifted from breakdown maintenance to periodic maintenance or predictive maintenance. All those things we will discuss in this thing. So, and the glossary of IAEA. It gives a definition of breakdown maintenance. That means action that restore by repair, overhaul or replacement the capability of the failed SSC. But there is a need, why to allow it to fail? Why not we do some preventive maintenance? Or why can't we do some periodic maintenance based on understanding of the, having a broad understanding of life of the component? So then what we see here is the periodic maintenance came into existence. Okay. So that is where a periodicity was attached to a type of machine, and how that periodicity came? That periodicity came because of knowledge of equipments. First of all, the data will be available from the vendor, if the vendor gives, of course. So in terms of mean time to failure or whatever, so that might give a periodicity input for periodicity of maintenance. Then the experience of the plant people, and experience of other plants which are working in the same domain, and those kind of things, they brought in the concept of periodic maintenance. Okay, but somehow it was felt that even periodic maintenance also, it is like qualitative expert opinion. Okay, based on that it was built. So of course it will be different for structural system, mechanical system, electrical, electronics and all that. But yeah, a large part was achieved, that is by periodic maintenance. The failures were avoided before we encounter a failure event. And the definition wise, it is a preventive maintenance program. So the preventive is very important here. So in preventive means even we can take some conservative approach, and we can have little extra time before we do the maintenance actually. So program consisting of servicing, part replacement, surveillance testing at predetermined interval of calendar time and operating time and all. So this is basically periodic, and then we have this preventive maintenance. Preventive maintenance added to the periodic maintenance, periodic main matrix it remained, but the concept of prevention of failure also came. So there it came somewhere like surveillance, if any deviation is there, any foul sound or smell is there, so we could avoid the failure. Okay, and then whether the immediate maintenance is required or we can pull on those kind of course. Once the moment is captured, then decision can be taken, and it is very easy. So if you look at the definition of this preventive maintenance, it is action that detect. So you see, from periodic repair it came detection, preclude, predict or mitigate degradation of SSC to extend its useful life by controlling degradation and failure to an acceptable level. So this definition came, and this is again I think from it is from IEA glossary, International Atomic Energy Agency glossary. And then it became sort of a proactive element got added into it based on the symptoms that are available in the area or in the control room anywhere. Also PM is generally planned in the periodic nature, though essentially it is planned, but surveillance add to it. It brings in a prediction component, or it becomes the component of detection. So that way preventive maintenance based on periodic dominating thing, but along with the surveillance and sensors, if we get from the sensor, then it becomes a condition monitoring thing. We'll discuss in the coming stay when we discuss the next evolution in the next presentation. So here we have reviewed all the past maintenance strategies and seeing the state of the art, but some more components are there which we'll be discussing in the next slide. In this slide, let us discuss state of the art in maintenance. So nowadays we see computerized maintenance management system. Earlier this same job was done manually, but now whatever each like there, earlier we were maintaining the card for each component or equipment or a system, and now what happens is there is a computerized card which will ask question, or which will you have to fill the slot, and then we can extract the information, what was the mode of the failure in last 10 years and all that, and accordingly this system tries to help to shape and reshape our maintenance strategy, and this is what is taking it to risk-based or reliability-based maintenance. We will discuss later on. And then online condition monitoring also has become part of. So state of the art today includes condition monitoring also. There are some equipment which are critical, where redundancy cannot be provided because of other constraints. So there the failure of the equipment will affect the plant availability. So there whether it is a bearing where we do continuous monitoring of oil level, continuous monitoring of temperature, vibration. So this becomes a condition maintenance. That means before the failure occurs, we will be able to take the action. And bearing failure, if it happens, and if it has got a fire event that gets postulated, then probably it has got safety significance also. So maintenance is not having a attribute of availability or unavailability, but it has got a component of risk also. That's why maintenance plays a dual role, risk reduction and availability optimization or increasement. And then the PRA insights form, this is like test and maintenance information and all, maintenance so in PRA model, you might feel that it is a risk, but no, all this reliability and availability based information, at least to 90%, they form part of a PRA modeling. Like demand related failures, it has got something that a failure was remaining passive either through maintenance activities, previous maintenance or testing activities. Okay. So, and then if my pump start for emergency, it has to operate for certain period of time to complete the mission. So, it is a reliability related information. That means all the essential feature and critical aspects are covered. So, like traditional approaches, ramps, people think reliability, availability, maintainability, they have distinct characteristic, but no, they are having overlapping characteristic. And in a risk model of the plant, all these essential and safety significant, risk significant thing can be captured, and that is what the objective of the, if we cover that. In fact, even if the component, there is a unsafe event happens, risk is a component. Now, how long plant will remain shut down? That also has got, you have to answer it. So, availability get added from there also. So, these quality, modern edit, assessment of methods and plant, they really become part of it. And most important thing, if in any maintenance ecosystem, root cause analysis, precursor monitoring program is not there, then RCCM, Risk Conscious Maintenance Management, says this should become part of it, because similar root causes can be there in many places. It could be related to environment, it could be related to human factor, it could be related to some maintenance methods, they will get corrected. So, now we have got in this slide the state of the art, and here I am giving, because this may be new to many people, refurbishment. Refurbishment is nothing but extended maintenance activity where broad decisions are taken in the context of keeping the plant up for another 10-15 years. So, accordingly, major overall shutdown activities are taken up, and once those activities are completed, it might include repair, replacement, or reconditioning for structural system. It is mostly related to reconditioning of the structural system, because replacement and they become life limiting components. So, they have to be repaired in situ and conditioned. So, this is called the, so the definition of refurbishment is connected intuitively with the plant life extension management items. And we have, I think you would have got enough background on RC, risk conscious maintenance management. I am adding two more RC, T and maintenance. So, I am testing test also here. So, later on we will see when we will discuss the application. We saw the life cycle curve, which enabled us to understand a broader perspective or broader canvas of maintenance management, and then evolution of maintenance program, and in next lecture the role of risk informed and risk based, because RCMM has drawn many principles and methods from RCMM framework. So, we will discuss those things. Thank you.